Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound gives a negative tolerance test, ruling out aldehydes, which would give a positive tolerance test. The compound gives a positive test with 2,4-dinitrophenylhydrazine, 2,4-DNPH, which is positive for both aldehydes and ketones. Together, these two results confirm the compound is a ketone. Moving on to the next step. Option C is an aldehyde, HC is equal to O group, so it is eliminated because it would give a positive tolerance test. Moving on to the next step. C6H12O. All remaining options A, B, and D are ketones with formula C6H12O. And for the final step, the compound must be optically active, meaning it must have at least one chiral carbon, a carbon bonded to 4 different substituents. Option A, CH3C is equal to O, CH2 CH, CH3 CH3. The carbon-bearing CH3 has groups CH3 H, CH2C is equal to O, CH3, CH3 to CH3 groups are identical, so this carbon is not chiral. No chiral center not optically active. Option B, CH3C is equal to O, CH, CH to CH3, CH3. The carbon alpha to the carbonyl bears H, CH3, CH to CH3 and C is equal to O, CH3. All 4 substituents are different. This is a chiral center. Therefore, compound B is optically active. Option D, CH3C is equal to O, CH2, 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 CH3. This is a straight chain ketone, 2-hexanone, with no chiral center not optically active. Only option B, which is methyl-sec-butyl ketone, 3-methyl-2-pentanone or methyl-1-methylpropyl ketone, satisfies all conditions: ketone, negative tolerance, positive 2,4-DNPH, and optically active, chiral center present. Therefore, the correct answer is B. Therefore, the correct answer is option B.